Welcome students, my name is Dr. Praneeth and today let's see the third part of the unit first, which is the benzene and its derivatives. So in the last two parts we have seen introduction and some electrophilic substitution reaction of benzene, and today we will continue this topic and we will see today two important reactions of benzene, that is Friedel-Craft's alkylation and Friedel-Craft's acylation reactions. So let's move on to this topic. So Friedel-Craft's alkylation reaction of benzene. So what is this Friedel-Craft alkylation reaction? It's a reaction about a carbon-carbon bond formation between the benzene ring and an alkyl group. Okay, so we already know the benzene ring contains 6 carbon, right? In each corner there is 1 carbons. So total is 6 carbons. So what is this alkyl group? Alkyl group is a CH3 based group, CH3, CH2, CH2, like this kind of groups. So benzene can react with the alkyl halides, which is alkyl group with an bromo or chloro or iodo groups in the presence of Lewis acid catalyst. We have already seen what is Lewis acid, right? We have Lewis acid is an acid which accept an electron pair. So that means it can accept 2 electrons from an base. So it's called as Lewis acid. So in this Friedel-Craft's reaction, we use AlX3 as the Lewis acid. We'll see in a short while what is this X stand for. Al is for aluminium. So it's aluminum halide. To produce the product is alkyl benzene. Okay, so benzene containing some alkyl groups. So let's see a reaction, a general reaction of this Friedel-Craft alkylation. Here is the benzene. Okay, 6 carbon with given only 1 hydrogen in this one. It actually contains 6 hydrogens plus alkyl halide. It's written as Rx. So we will see in a short while what is R and what is X stands for, and it also reacts in the presence of Lewis acid catalyst, that is the aluminium halide, right? Aluminium halides. So what is this Rx? Rx is an alkyl group. R is an alkyl group, like this kind of groups as shown in this blue. CH3, CH2, CH2. So can be a long chain or can be a branched chain also. So all this CH2, CH3 groups, CH, all these groups are called as alkyl groups. X stands for halide. Halide meaning it can be either chloride, bromide, iodide and fluoride. So it can be anything. So Rx meaning it contains alkyl group and an halide group. So it's a combination of alkyl group and an halide group. It's called as Rx group. So let's move on to see the reaction. Benzene react with alkyl halide, right, in the presence of Lewis acid catalyst to produce alkyl benzene as a product. So alkyl benzene, in alkyl benzene, benzene is attached to an alkyl group, that is an R group, okay, plus Rx, HX as the byproduct. So basically you can see that this hydrogen gone here to attach with this X to give the acid HX, and the R, the alkyl group, go into the benzene ring and attach to the benzene ring to give the product alkyl benzene. Let's see an example of this reaction, a real example. So benzene react with methyl chloride CH3Cl in the presence of aluminium chloride AlCl3. Okay, so this is a real example, aluminium chloride, trichloride or aluminium chloride and methyl chloride. So it's alkyl group and an halide group. Right? Alkyl halide, here I have given methyl as an example, CH3. CH3 is called a methyl group. To produce a methyl benzene. Methyl benzene is also called as alkyl benzene, right? Methyl is an alkyl group. So let's see the reaction. Benzene, here is the benzene, okay, and it reacts with methyl chloride CH3Cl in the presence of Lewis acid AlCl3 as shown here to give methyl benzene as a product. This is a product plus HCl as the byproduct, acid as the hydrochloric acid is the byproduct, HCl. So you can see the methyl benzene is the product. So this is the complete reaction of Friedel-Craft alkylation. So you start with a benzene and you treat with methyl chloride, and you also need to use this Lewis acid Alcyl3, and you can get a C bond formed product. So you see that carbon present in this benzene here and this carbon from the methyl group attached to give this methyl benzene as the product. Let's go deep into the reaction and explore the reaction mechanism, how the reaction proceed. So this reaction, we will see the reaction mechanism of this very important reaction, Friedel-Craft alkylation reaction. So in the reaction mechanism, we always have steps, right? First step, second step, third step, fourth step, like that. In the case of Friedel-Craft alkylation reaction, this actually consists of 3 steps. Okay, it consists of 3 steps. So let's go one by one from the first step. So the first step contains the methyl chloride, that is the reagent, right? In the first step, methyl chloride reacts with aluminum chloride AlCl3 to form an unstable complex. So this first step is forming the unstable complex, so that this unstable complex can decompose to produce this important methyl cation, that is the electrophile, right? Methyl cation is CH3 plus. So this is the formation. In the first step is the formation of the methyl cation, that is the important point here. So let's see how the reaction proceeds. So here I have shown the methyl chloride CH3Cl plus this Lewis acid AlCl3. So what you get is this unstable molecular complex as shown here, right? CH3Cl with a bond forming between these 2 reagents. Okay, the starting material reacts and form a bond, but this bond, this complex is unstable because the chlorine has a positive charge. Normally, this kind of complexes are very unstable due to this unstable nature of the positive charge on the chlorine. Normally, chlorine should not have any positive charge on it. So this molecular complex can break down easily to form this electrophile CH3 plus. Okay, and then to balance the charge, AlCl4 minus has also formed. So this can coexist in the solution. So this is the first step, formation of methyl cation. So this is the important point here in the first step. So what happens in the second step? So this methyl cation goes into the second step, right? So this methyl cation reacts with benzene in the second step. So in the second step, I only give the CH3 plus. I will avoid using the AlCl4 minus for simplicity reason. So don't get confused. It's always present as the coexist as in the solution. So let's see in the second step. We already know that benzene is electron rich because it consists of pi electrons. We already seen in the introduction. So this electron rich benzene can easily react with this methyl cation, because methyl cation is a positive charge. Electron rich benzene, the electron is having many negative charges, right? So it contains a partial negative charge, so it can easily react. Electron and proton can easily react. So this is what happens in the second step. This is the benzene I have shown here with only one hydrogen I have shown for simplicity. So what happens? This benzene pi electrons, right? Inside this is a pi electron. This pi bond, 3 pi bonds contain 6 pi electrons. So these electrons flow and attack the CH3 plus electrophile to give this kind of products. This resonance stabilized intermediate formation can happen. So here this is the product formation, that is the resonance stabilized intermediate. So first this bond goes and attack here and forms a new bond between the benzene and the CH3 plus. So you can see here, like this is a new bond formed. Okay, and because of the electron moved from here to here, okay, this carbon gets a positive charge because it lost one electron. Okay, it's pi electron, so it becomes a positive charge here, and this positive charge is stabilized by this inner electrons. This inner electrons moves here, and this positive charge gets stabilized, right, like we have seen in the other cases also, bromination and chlorination reaction, nitration reaction. So similar thing happens. So this bond goes here and the positive charge comes here, like this one. So this, you can get this structure, this stabilized structure, and this positive charge, this electrons comes here, this bond comes here, and this positive charge moves here, okay, and this carbon get the positive charge. Like that, it can circulate and make it stable for some time, so that the third step can proceed. So this is what happening in the second step. This electron rich benzene attacks the electropositive CH3 plus ion and form this resonance stabilized intermediate. So this point you have to remember, what is happening in the second step. Final step is the formation of product, which is shown here. This is the final step. In the final step, importantly, the proton transfer occurs. So this proton, this hydrogen, is transferred to this AlCl4 minus. So where this AlCl4 minus is coming? So this AlCl4 minus is coming from the first step, right? The electropositive CH3 plus is created along with this AlCl4 minus. So this is coexist. So this comes in the second step and can abstract, take this proton, take this hydrogen. So this is shown by this red arrow. You can see that this proton moves here and attached with this AlCl4 minus, and at the same time this bond, this electrons moves inside. This is shown in this second arrow. So this bond moves into the inside of the ring. So what happens? You will get the product. You will get the methyl benzene as a product. What other things are happening? You will get also the HCl, because this hydrogen goes here and takes one chlorine and forms HCl acid, and also AlCl3, that is this Lewis acid catalyst, is regenerated in this reaction. So these are the detailed reaction mechanism of this reaction. In the first step, you will get the formation of electropositive CH3 plus, and in the second step, the CH3 plus react with the benzene to form this resonance stabilized intermediate. Okay, so this reaction stabilized intermediate is formed, and which can cycle through the shifting of this double bond inside. And finally, in the third step, proton transfer occurs. This proton transfer here, and this bond is moved into the benzene ring to form the methyl benzene as the product, plus HCl and AlCl3. So this is the total mechanism of Friedel-Craft's alkylation reaction. So here in this example, I have given only this CH3 group, right? But it can also be any alkyl group like CH3, CH2, CH2, CH3, and branched chain alkyl group can be prepared by using this common Friedel-Craft's alkylation reaction method. So this I will show you in this Friedel-Craft's alkylation summary slide. So this is the general reaction scheme I have shown here, right? Benzene react with this Rx in the presence of AlCl3 to give this alkyl benzene, R attached to the benzene. R is the alkyl group and X is the halide group I have shown before. So if we change the R as the CH3, okay, as shown in this reaction scheme, and if we change the X to Cl, so we will get the methyl chloride. We have seen just before this reaction with the detailed mechanism also. In the presence of AlCl3, you get the methyl benzene, right? So if we change this R group to CH3, you will get this CH3 attached benzene ring in this product. So what happens if we change the R to CH2 CH3? This I have shown here. See the same benzene, and it can react with this ethyl chloride. Ethyl chloride is nothing but CH3 CH2 Cl. Okay, methyl chloride is CH3 Cl. So react with the ethyl chloride in the presence of AlCl3, you will get ethyl benzene as a product plus HCl. So this is the very important um, strategy behind this Friedel-Craft alkylation reaction. If you change this R group, you will get different products, different important products. Let's see one more example of this. If you change the R group to this isopropyl group, isopropyl is CH3, CH, CH3, this group, okay, this group, CH3, here it is CH, okay, even though it is nothing here, it is a carbon, okay, it's like this benzene, I have not, no one could carbon, but it is understood that there is a carbon here. So this is the isopropyl group. So if we take benzene and react with this isopropyl chloride, you will get this isopropyl benzene. So this isopropyl benzene is attached. Like that, if different R groups, you will get different type of products. So far we have seen what is Friedel-Craft's reaction, right? It is a carbon-carbon bond formation reaction between a benzene ring and an alkyl chloride group, okay? And we have also seen the detailed reaction mechanism of this Friedel-Craft alkylation reaction, how this reaction occurs through different steps. And finally, we have seen how to get different types of alkylated benzene product by simply changing this R groups. So with this, we will next move on to see the Friedel-Craft's acylation reaction. So far today we have seen this alkylation reaction. Let's see what is this acylation reaction. So what is this acylation reaction? What is this acylation reaction? So acyl group is this CH3CO group. Okay, alkyl group is simply the CH3CH2, CH3, CH2 group. So in the acylation it contains CO carbonyl group also. This is called the acylation group. So how this reaction proceeds for benzene, we will see from now on. So in the Friedel-Craft acylation reaction, what happens? First, a new carbon-carbon bond is formed between the benzene ring and an acyl group. Okay, previously it's a carbon-carbon bond reaction between benzene and alkyl group. For the alkylation, here it is an acyl group. And then the benzene react with this acyl halide, which is RCOX, in the presence of Lewis acid catalyst, like similarly in the last reaction, to produce acyl benzene. The acyl benzene is a product here in the case of this reaction. Let's see the general scheme of this reaction. The general scheme I have mentioned this benzene like this plus the acyl halide, okay, acyl halide, ACYL, acyl. It is called as RCOX group. RCOX, acyl halide, X is halide, it can be chloride, bromide or anything. And in the presence of AlX3, AlCl3 or AlBr3, anything. So here I have given some examples of this acyl group, right? This acyl group, acyl halide. So acyl group is nothing but a CH3CO group. So you should attach a CO group with the alkyl, then it become acyl group. So here also CH3CH2CO group. And if you change the alkyl group to a benzene, right? This benzene attached to CO, it is called as benzoyl group, acyl group and benzoyl group. So this is also an acyl group. So let's check back this reaction. What happens with the benzene react with acyl halide, okay? So you will get this product acyl benzene. Acyl benzene is the product of this reaction plus HX as the byproduct. So now let's see a real example of this Friedel-Craft acylation reaction. So this is a real example. Benzene here I have given and reacts with this acetyl chloride. So acyl group is the CH3CO group in this example, and if you have a chloride, then the name of this chemical is acetyl chloride. So it reacts with AlCl3 and you can get this acetyl benzene as the product. So the COCH3 group is attached to the benzene ring in this ring, and you also get HCl as the byproduct, okay, in this reaction scheme. So with this example, we can go deep and check what is the reaction mechanism, the detailed reaction mechanism involved in this reaction. How this benzene react with the acetyl chloride to give the acetyl benzene as a product, how this reaction proceed. So let's explore this reaction. So through this reaction mechanism of Friedel-Craft acylation reaction. So here also, like the other reaction we have seen before, the acylation reaction also involves 3 steps. Okay, it also involves step 1, step 2, and step 3. So what happens in the step 1? In step 1, acetyl chloride, that is the acyl chloride, right? Acetyl chloride as example, react with the AlCl3, as this is a Lewis acid, to first form a molecular complex. Unstable molecular complex is formed. Similar to the alkylation reaction, same thing happens in this step 1 also. And then this molecular complex, as we already know, this is unstable, it decomposes to form the acetyl cation. So let us see this in a reaction form. So this is the acetyl chloride. Acetyl chloride reacts with AlCl3. This is a Lewis acid. So what happens is the new bond is formed between acetyl chloride and AlCl3, right? This is a normal way. So this is a new bond. This one is formed between these two reagents to form this molecular complex. Okay. So this molecular complex, as we know, this is very unstable because of the positive charge on the chloride. So whenever you see a positive charge on the chloride, it is really unstable. So this bond breaks, okay, this bond breaks here and form this acetyl cation, CH3CO plus. Okay, I have written like double bond O, but you can also write as CH3CO plus. So this double bond bro, you can write or you do not need to write. So just for more clarity, I have given here. Plus again, you will also get AlCl4 minus as the charge compensation form. So what is the important step involved in the first step is the formation of this acetyl cation. Okay, so then what happens? So this acetyl cation goes into the second step, right? It attacks benzene ring, it attacks this acetyl cation. So as we know before, benzene is electron rich. So this electrons inside the benzene ring attacks the CH3CO group. So what you get is this resonance stabilized intermediate species. Okay, so this intermediate species is generated and a new bond is formed between benzene and this CH3CO. So the bond is formed between this carbon and this carbon. Okay, you have to make sure to understand this important point. The bond is formed between this carbon in this CH3CO with the carbon present here on the benzene ring. So what it forms is this new bond with COCH3 attached on the benzene ring. So we will get this resonance stabilized species having a positive charge on the carbon here on this carbon, because this bond moved here, right? This bond moves here, so you will get a positive charge here. This is the one intermediate, and to get stabilized, this intermediate should be stable enough to react further in this third step. This is very important. So for that, to make it more stable, this bond moves here. Okay, this bond moves here and forms the positive charge here. Like it's very similar, very same like this alkylation reaction. And this bond again moves here and forms the positive charge, goes on to this carbon as shown here. Okay, this carbon. Like that, it stabilizes this intermediate. And finally, this resonance stabilized intermediate move on to the final step, that is the third step, right? So this is the last step in this mechanism of acylation. In the third step, proton transfer occurs to generate the product. The product is acetyl benzene. Acetyl benzene is a product here. So this is the resonance, one of the resonance stabilized intermediate. I have taken only one. I don't want to take all the three resonance stabilized intermediate because it is all same. So I can take any one of the resonance stabilized intermediates. I took this structure in the third step to make it more simplified. So what happens here? A proton transfer occurs, right? So for this one, I've shown using this red arrow. The proton from here is moved to the AlCl4 minus. At the same time, this bond having electrons, right? Each bond contains 2 electrons. This bond moves inside to the benzene ring because benzene ring is having a positive charge. So this electrons automatically moves towards the positive charge to make it stable. So in this way, what you get is the product, the final product. The final product contains the 3 double bonds in the middle of the benzene ring, and you also get COCH3, this COCH3, and this hydrogen moves to the AlCl4 and attach with one chlorine to form this byproduct HCl, hydrochloric acid, and AlCl3 as the Lewis acid catalyst. So in the third step, you get the desired product, acetyl benzene. Similar to the alkylation reaction, you can also change the CH3. Instead of the CH3 group, you can change different group. Like instead of methyl group, you can change to ethyl. Okay, so you get the, what is the product then? This is acetyl benzene, that is the ethacetyl benzene, right? Like that, you can change the R group and get the different products in the reaction. So, so far we have seen 2 reactions today, 2 very important reactions. One is the Friedel-Craft alkylation and the next one is this acylation reaction. And in this 2 reactions, we have seen how the reaction proceed through different steps in the reaction mechanism. And also we have seen that by changing our group like CH3 to change to different groups, we can get different types of product. Like methyl, if we start with methyl, you'll get the methyl benzene, right? If we change with ethyl, you get the ethyl benzene in alkylation reaction. Similarly, if we change to this COCH3 to COCH2 CH3, you'll get this group attached in the product. So this is a very important, these 2 reactions are very important to make the CC bond, carbon-carbon, new carbon-carbon formation between benzene and other chemicals. So this is for this is all for today's session, and in the next session we will see more reaction of benzene like sulfonation reaction, and also we can explore about the derivatives of benzene and their uses and application in pharmaceutical chemistry. So thanks for your attention, and we will see you in the next class. Thank you.